So welcome to another session of Everyday Mathematics. Today's problem comes from MIT 2024 Integration B regular season, problem number 5, which is the indefinite integral of cotangent or cot x times cot 2x. So this is an interesting problem, not very hard, but interesting all the same. I'd like to thank our subscribers. Thank you so much for your support. We don't take that support for granted. Our first-time visitors, what we do here at Everyday Mathematics, we go about and around and look for interesting problems. We come back and share with you the solutions that we think befit these problems. To our repeating visitors who haven't subscribed, we do really encourage you to consider subscribing to our channel. So this problem is interesting. First thing that I personally would do is I could express the cotangent functions, cotangent x and cotangent 2x in form of sine x cosine x sine 2x cosine 2x respectively. So as we can see, this function is the same as the integral, or the integral of cotangent x cotangent 2x is the same as the integral of cosine x over sine x times cosine 2x over sine 2x, sorry. And so keeping the single angle formalism as they are, we could now go ahead and express 2x as 2 sine x cosine x. So what that results into is this cosine x would cancel with that. So we have in the numerator 1 times cosine 2x. In the denominator we have sine x times sine 2 sine x. So cosine 2x can be also expressed as cosine squared x minus sine squared x. And then denominator, we have 2 sine squared x. So we can pull the half out so that we have the integral of cosine squared x by over sine x is cotangent squared x. And then sine squared x by over sine squared x is 1. So this is interesting. We could also now go ahead and say if we have the identity cotangent squared x plus 1 equals to cosecant squared x, that means that our integral now could be transformed by substituting cotangent squared x being equal to cosecant squared x minus 1. So if we plug this into our integral, now we have half the integral of cosec squared x minus 1 minus 1. And so that means that we have half the integral of cosec squared x minus 2, and multiplying half across, so we have integral of a half cosec squared x minus 1. So this means that the integral of cosec squared x is the same as negative cotangent of x, and we'll prove why that is the case later. And then the integral of negative 1 is negative x plus integration constant c. So this is the answer. There's another way of looking at this problem is by expressing cotangent x and cotangent 2x in form of tangent x and tangent 2x respectively. So of course cotangent x times cotangent 2x is the same as 1 over tan x times 1 over tan 2x. Then we know that tan 2x is the same as twice tan x over 1 minus tan squared x. So substituting these in place of these, we get that cotangent x, cotangent 2x is the same as 1 over tan x here times 1 over 2 tan x divided by 1 minus tan squared x. So the reciprocal of this becomes now 1 over tan x times 1 minus tan squared x over 2 tan x. And so multiplying tan x and 2 tan x becomes 2 tan squared x. So we have now, by pulling this half out here, we have half 1 minus tan squared x over tan squared x. Then 1 minus tan squared, 1 divided by tan squared x is the same as cotangent squared x. Tan x divided by tan squared x divided by tan squared x is 1. So we go back to the same expression of half cotangent squared x minus 1, which reduces to a half cosec squared x minus 1 minus 1, which is cosecant squared x minus 2, which is a half cosec squared x minus 1. And then when we integrate that, we get the integral of half cosec squared x minus 1, which we found out to be negative half cotangent x minus x plus c. So this is obvious, very obvious, based on the first solution that we're able to derive. But we would also like to show why the derivative of cotangent x is the same as negative cosec squared x. So if you differentiate cotangent x is the same as the derivative of cosine x over sine x, which is using the product rule, 1 over sine x times the derivative of cosine x plus cosine x times the derivative of 1 over sine x. Now, if you know that the derivative of capital U over V, capital V, is equals to V, the derivative of capital U, minus capital U, the derivative of capital V, yeah, over V squared, the quotient rule of differentiation. That means that when we focus on the derivative of 1 over sine x, V is sine x, U is 1. So what that means is for the first part is 1 over sine x, the derivative of cosine x negative sine x. Cosine x, now the derivative of 1 over sine x, the denominator, V squared is sine squared x. V being equal to sine, and then the derivative U, the derivative of 1 is 0, minus U being 1, derivative of sine x is cosine x. So we have 0 minus cosine x. And so this and this cancels, but we have negative 1 here, minus cosine times cosine, this cosine squared x over sine x. So which is negative sine squared x plus cosine squared x over sine squared x. This identity is equals to 1. So we have negative 1 over sine squared x, which is negative cosecant squared x. So, and this here brings us to why we're able to obtain cotangent x when we negative cotangent x when we integrated cosecant squared x. So that's the quick of it. Thank you so much for following along. If you have any question, please leave your comment or question in the comment section. We'll definitely get back to you, but it's been an absolute pleasure running through this problem. Until next time, be safe. Bye-bye.